In this video, we're going to talk about the dot product. Sometimes also called the scalar product. The dot product of the vectors a and b is equal to the magnitude of a times the magnitude of b times the cosine of the angle in between them. So in other words, a dot b is equal to magnitude of a, magnitude of b, cos theta. So given the magnitude of A is 7 and the magnitude of B is 4 and that there's an angle of 60 degrees between A and B, evaluate A dot B. A pretty straightforward question. A dot B will equal the magnitude of A times the magnitude of B times cos theta. 7 times 4 times the cosine of 60 ultimately equals 14. How about if the magnitude of A is 9 and the magnitude of B is 5 and the angle in between them is 140 degrees? What would the value of A dot B be? Well, in that case, A dot B would be the magnitude of A, magnitude of B, cos theta, which would be 9 times 5 times cosine of 140 degrees, which would ultimately equal approximately negative 34.5. So we've got that formula here. And one thing you might have noticed from the previous two questions is that in both cases, we got a scalar. A dot B requires A and B to both be vectors, but it provides you with an answer that is not a vector. It's just a scalar. Now we can assume that neither A nor B have a magnitude of 0. And so in other words, simply logically speaking, if either of the vectors was the 0 vector, we wouldn't be able to determine the angle it made with the other one. So there'd be no direction to it. So we can assume that. And so since A is going to be the magnitude of A is going to be positive and the magnitude of B is going to be positive, then the sign, whether positive or negative, of A dot B will be determined ultimately by cos theta. Well, cos theta is greater than 0 if theta is an angle between 0 and 90 degrees. Cos theta equals 0 if theta is equal to 90 degrees. And cos theta is less than 0 if theta is an obtuse angle. So putting all that together, we can say that A dot B will be a positive value if theta is acute. It will equal 0 if theta is 90. And it will be negative if theta is obtuse. This right here, A dot B equals 0 if theta equals 90 degrees, that is a significant part of this course. Okay? So if the dot product of two vectors is 0, the vectors are perpendicular. That's something worth remembering. So let's do another example. Determine the value of A dot A if the magnitude of A is 7. Well, we know the angle between A and A will be 0 degrees. If it helps you to see a diagram, imagine the vector A is shown on your screen in red. Well, if we drew the vector A again, tail to tail, we'd see that at tail to tail they both met at that point on the far left in my diagram. We would see that the angle there would be 0 degrees. So A dot A would be the magnitude of A times the magnitude of B, the magnitude of A times the magnitude of A times the cosine of 0 degrees. Well, the cosine of 0 degrees is 1. So it would be the magnitude of A times the magnitude of A times 1, which in this case would be 49. And so we can say as a general rule that if we dot a vector with itself, a non-zero vector, the dot product will just be the magnitude of the vector quantity squared. Now let's talk about some properties of the dot product. Very convenient, friendly ones. First of all, A dot B will equal B dot A. Secondly, MA dotted with B will be equal to M times A dot B. Thirdly, the distributive property works with dot product. So A dotted with the sum B plus C will be equal to A dot B plus A dot C. That's a very convenient one. And it works if we have more than just one vector distributing as we had in the last one. If we have A plus B as a quantity dotted with C plus D, that will equal A dotted with C plus A dotted with D plus B dotted with C plus B dotted with D. That's pretty convenient. So now let's do a more complicated question. Suppose the vectors a plus 3b and 4a minus b are perpendicular, and suppose that the magnitude of a is equal to 2 times the magnitude of b. We want to determine the angle between the vectors a and b. Well, we know that since a plus 3b and 4a minus b are perpendicular, therefore a plus 3b quantity dotted with 4a minus b quantity should equal 0. Well, we can distribute a dotted with 4a, which is the same as 4a dot a, plus a dotted with negative b, which is the same as negative a dot b, plus 3b dotted with 4a. 3 times 4 is 12, and then instead of b dot a, we'll say a dot b, so we get 12a dot b. And 3b dotted with negative b, which is negative 3b dot b. All of that should equal 0. Well, we can collect up our like terms. Negative a dot b plus 12a dot b will be positive 11a dot b. Negative 3b dot b will be negative 3 magnitude of b quantity squared. 4a dot a will be 4 magnitude of a quantity squared. And so we'll get this second last line here. And our strategy here, because we want to know the angle between a and b, our strategy is going to be isolate a dot b and then go from there. We want to isolate a dot b because a dot b is a formula that contains cos theta in it, where theta is the angle between the two vectors. So if we can isolate a dot b, we'll be able to isolate cos theta, use cos inverse, determine theta. So we are going to isolate a dot b. What we'll do is we'll throw negative 3 magnitude of b squared on the right, and then positive 4 magnitude of a squared on the right, and we'll ultimately get what you see here. 11a dot b is equal to 3 times the magnitude of b quantity squared minus 4 times the magnitude of a quantity squared. Now, we know that the magnitude of a is 2 times the magnitude of b. So what we're going to do is, instead of magnitude of a right here, we're going to put 2 times magnitude of b. Instead of magnitude of a quantity squared here, we're going to put 2 times magnitude of b and then that entire quantity squared. So this is again what we have in the previous line. 11 times 2 is 22, so we get 22 times the magnitude of b quantity squared times cos theta. 2 times the magnitude of b quantity squared is the same as 2 times the magnitude of b times 2 times the magnitude of b. 2 times 2 is 4. And so, 4 right here. So we get 2 times 2 is 4 magnitude of b quantity squared. But we had that 4 in front. So this is what we ultimately get there. So what we ultimately get is 22 magnitude of b quantity squared times cos theta equals 3 times magnitude of b quantity squared minus 16 times magnitude of b quantity squared. Collecting like terms here on the right-hand side, we get negative 13 magnitude of b quantity squared. And on the right, we have 22 magnitude of b quantity squared times cos theta. So we can now isolate cos theta. Cos theta will be negative 13 times magnitude of b quantity squared over 22 times magnitude of b quantity squared. B is a non-zero vector, so the magnitude of b will be positive. So magnitude of b quantity squared will be positive. So we'll be able to say cos theta is negative 13 over 22. And remember, theta is the angle between a and b, which is what we're looking for. So since cos theta is negative 13 over 22, theta will roughly be equal to 126.2 degrees. Now, in this next example, we'll say that since it will prove that if the magnitude of x plus y is equal to the magnitude of x minus y, and if x and y are non-zero vectors, then that would mean that x and y must both be perpendicular. So how will we do that? Well, we begin with the statement given, magnitude of x plus y equals magnitude of x minus y. And then we remember that if we're talking about perpendicularity or angle between two vectors, we probably want to involve dot product. And that we have this really neat formula that we talked about a minute ago. The magnitude of A quantity squared will be equal to A dot A. So if we square both left and right side of that, we'll then be able to use this formula, bring the dot product into the question, and then be able to consider angles between vectors that way. So what we're going to do, we're going to square both sides, and that'll get us to this statement here. We'll say that x plus y, the magnitude of that squared, is equal to x plus y dot x plus y, and that the magnitude of x minus y quantity squared is x minus y dot x minus y. We'll then distribute x dot x plus x dot y plus y dot x, which is the same as x dot y plus y dot y. We'll get this here. And then on the other side, we'll have x dot x minus x dot y minus x dot y plus y dot y. And we'll get this right here. Now, we can collect up our like terms. We'll have 2x dot y on the left, and we'll have negative 2x dot y on the right. We'll have an x dot x, which cancels with x dot x, and a y dot y, which cancels with y dot y. So ultimately, what we're going to have is 2x dot y on the left equaling negative 2x dot y on the right. Okay, and so this is what we show here. We show, crossing out x dot x and y dot y. We stated it a little bit more sophisticatedly by saying subtract them from both sides. Then we collect up our like terms. We have 2x dot y, and then we have negative 2x dot y. Adding 2x dot y to both sides will get us to 4x dot y equals 0. And dividing both sides by 4 will get us to x dot y equals 0. But remember what we said a while ago, if the dot product of two non-zero vectors is 0, that means those vectors are perpendicular. So we can say x and y are perpendicular, which is what the question was asking us to show.